Good day everyone. Today I will discuss the Deep Foundation reference for Metro Manila, Philippines, presented by Sinamban Ronald Maron M. BS Civil Engineering 5. Okay, firstly, let's talk about the presentation. The presentation focused on the analysis of the pile capacity and the pile length for various cities of Metro Manila. The standard penetration test (SPT), the end values from the soil reports were used to compute for the geotechnical parameters such as undrained shear strength and the angle internal friction, which is directly applied in the computation of the allowable pile capacity. The estimation of the pile length, on the other hand, was done by means of determining the depth of the refusal of rock layer. Moving on, let's talk about introduction. Metro Manila's buildings are comprised of at least 70% high-rise building and skyscraper, excluding for the cities of Caloocan, Navotas, Las Piñas, Pateros, and Malabon due to absence of data. At some geological past, the Metro Manila was submerged underwater, which extend up to mountains in the eastern part. Also, majority of the sediments present in the geologic deposit of Metro Manila are due to the bodies of water surrounding it, which include Manila Bay, Pasig River, and Laguna de Bay. This presentation will try to help structural engineers by giving them a reference for the pile capacity and pile length needed for the construction of a structure in need of the pile foundation in any specific place of Metro Manila. The main objective of this presentation are to estimate the necessary pile length for the different areas of Metro Manila and to determine the proposed pile capacity in the entire Metro Manila. Now let's go about the process. The aim of this presentation is to create a deep foundation reference for the district of Metro Manila. Borehole logs with the ratio of 1 borehole log per square kilometer were collected and compiled according as shown in the figure 1. A total of 677 boreholes located were collected and mapped. For the entire data or soil reports, it already comprised almost 86% of the total target. This number of data does not yet include the outskirts of Metro Manila, which are from Rizal, Bulacan, Cavite, and Laguna. The outskirt data were used to provide accurate mapping even at the near boundaries of Metro Manila. The data are then analyzed and calculated for the depth of rock information and geotechnical parameters. As you can see in the figure 1, this is the map of Manila with borehole locations. Moving on, let's talk about methods used in solving pile capacity. The number 1 is the alpha method is used to estimate pile capacity, especially for clayey soil layers. It's used as a factor denoted as in approximating the value of the skin friction and a coefficient NC to compute for the end bearing capacity. The skin friction for any types of pile using the alpha method include the coefficient, the undrained shear strength, and the lateral surface area of the pile. The second method is the beta method. It's similar to the alpha method in such a way that it uses coefficients, but this time it is denoted as for skin friction and NQ for the end bearing resistance. Unlike an alpha method, the beta method considers both sandy and clayey soils. The general equation using the beta method is quite. The skin friction for any types of pile using the beta method include the coefficient, the effective stress, and the lateral surface area of the pile. For a better visualization of the acquired data, and computation value, the allowable pile capacity values are then mapped out by means of contour maps, implementing verification of both the data accomplished and the procedure contour maps was done as well. The computed values of allowable pile capacity were stored in the GIS database as well. Okay, let's move on about the result and discussion of the deep foundation reference. The proposed pile length map for the entire Metro Manila can be seen in the figure 2. The map reflects the type of soil present where the majority of the area that is underlain by the Guadalupe Tuff Formation has a pile length that ranges from 5 to 10 meters in length. The majority of the data collected near the said body of water possess thick layer of alluvial deposits, namely sand, silt, and clay. Generally, the proposed pile length for Metro Manila range from 5 to 15 meters. As you can see in the figure 2, the proposed pile length. Several parts of the region show length ranging from 20 to 25 meters. The effect of Manila Bay in terms of pile length is manifested through these results. For the eastern part of Metro Manila, the proposed pile length range from 10 to 25 meters, which shows the effect of the location with respect to Laguna de Bay, where the majority of the data collected near the said body of waters possesses thick layer. Moving on, let's proceed to propose skin-to-tip ratio. The skin-to-tip ratio is the ratio between the skin friction and the tip resistance or the end-bearing resistance. The area underlain by the Guadalupe Tuff Formation produces low skin-to-tip ratio, whereas a high ratio is observed in area where alluvial deposits are prevalent. For the skin-to-tip ratio map, for Metro Manila, the values can also be reflected by the type of soil presented along those areas, as in the figure 3 and figure 4. For driven piles, skin friction usually contributes greater resistance than that of the end-bearing resistance due to the large adhesion factors. As you can see in the figure 3, proposed skin-to-tip ratio, board pile, and figure 4 proposed skin-to-tip ratio, driven pile. Finally, let's talk about conclusion and recommendations. The pile length and allowable pile capacity are determined through borehole slugs. For the city of Las Piñas, Malabon, Navotas, Pateros, and Pasig, they have relatively small allowable pile capacity as compared to the other cities for both driven and bored piles. Pile lengths are shorter because they have reached the refusal layers at somehow a shallow depth, thus layer skin friction is included. Moreover, based on the skin-to-tip ratio, skin friction still plays a great contributor over the end-bearing resistance all through, and totally an allowable pile capacity is still small as compared to other cities. There are cities in Metro Manila which are not recommendable for the shallow foundation just because the top layer are weak, especially in bearing capacity. This means that the high loading from the superstructure can be resisted by pile considering also its length. The trade-off, however, is that it is not cost-effective anymore due to the long piles that required a lot of materials. Thank you for watching and listening.